Here's a solution to another problem from section 6.3. This time we're forming a solid by revolving a region around the x-axis. I see that now. X-axis is there. So this guy's going to spin around the x-axis and sweep out a solid. So we know that when we do that, instead of thinking of the solid being generated by spinning and then slicing it, it's actually easier to think about slicing the region and then just thinking about what that spinning that one stick looks like. So this would be my slice. This coordinate will be x cosine of 19x. Everything's getting labeled in terms of x because I'm using a vertical slice. The position of the slice is based on the x coordinate, and so that means I'm going to use the x coordinate as my variable in the slicing process. So I can see in the picture that the possibilities for x are between 0 and pi over 38. So we know that will matter eventually. And so now all I need to do is picture what one slice looks like. So I'm going to pull this disk out. The disk looks like this, where the center to the edge is coming from, so this distance is coming from the length of the stick. So the stick is, the radius of the stick is just the size, sorry, the radius of the disk is the length of the stick. And this really is a slice. It has a little bit of thickness to it here. Thickness is coming from the thickness of the original slice. So it is a disk. The volume of that one disk is approximately pi times the radius squared times the thickness. The radius of the disk is the same as the length of the stick, which is cosine of 19x. So, and that's the radius, so we're doing pi r squared. So radius squared. So the volume of one slice is pi times cosine of 19x squared times the thickness, delta x. So therefore, the total volume is the sum of all these estimates, and in the limit that becomes curvely s pi cosine of 19x. Usually with trig, we write the squared there. I don't know why, but we'd do that. Makes there be less parentheses anyway. And as I said, the range goes from 0 to pi over 38. So values of x go from 0 to pi over 38 of all things. So that's the integral that will model this. Just to go ahead and do the next step, because they are reminding us about how we're supposed to do that. It doesn't look like it, but this really will be easier after we change the cosine squared into something with trig identities. So the trig identity says that the cosine squared of something, so all the rest of this is the same. And in fact, if I was smart, I would pull this pi outside this pi. I would write out here so I don't have to deal with it. But the cosine squared of something is the same as 1/2 1 plus cosine of twice the something. So I have to be a little careful here. Whatever this is, when because here it's double it, because this is coming from the double angle formula. So the main thing is that this thing in here is twice that thing. So if the thing inside the cosine square starts off being 19x, then the thing in here has to be 38x. It's twice whatever was in the cosine squared. So that's what I would have as an integral. And now this will work really well with a substitution u equals 38x. And we can see why 38x is just going to become u, and then we just have antiderivative cosine u. So that's very simple. To do that, of course, I have to also factor in how du and dx are related. Du is 38 dx, and so I'll have to factor that in as well. And don't forget that this is actually an x value, and this is an x value. And so you can see that if u is 38x, then when x is pi over 38, u is going to be pi, and this will be 0. So if I put all that together, I won't do it all the way through, but I'm going to pull this 1/2 out with this pi. So pi over 2. My u will now be 0 to pi. And instead of 1 plus cosine 38x, I'm going to have 1/38 1 plus cosine u. And the 1/38 is because of this relationship right here. Dx is 1/38 of du. Right? We should write that down. 1/38 of du equals dx, according to that equation. So I'm doing these two things and putting that in there. So this is what I get in the transformed integral, and now that is a very simple integral. Antiderivative cosine of u is sine of u, and I'm just plugging numbers in.